Very good. All right, page 4. Example 6. Solve the given initial value problem, second order differential equation, and we have initial values when x is pi over 3, y is equal to 0, and when x is pi over 3, y prime is equal to 2. And so what we're going to be able to do is we're actually going to be able to solve for c sub 1 and c sub 2. So we're going to treat this exactly like all of our other equations. And how to solve, and then once we found our general solution, we're going to be able to find our c sub 1s and c sub 2s. So let's go ahead. I'm going to write this just so that you can see it like all the other forms. Y double prime plus y equals 0, and then you can substitute in for that m squared plus 1 equals 0. And now that we have this, we can go ahead and solve for m. Now, I don't need to do the quadratic equation. I can subtract 1 from both sides, and I get m squared is equal to negative 1. Square root both sides, and m is equal to the square root plus or minus the square root of negative 1, which is just going to be plus or minus I. And so, once again, we realize we have complex roots, but once again, that's not bad because we know what our alpha is and we know what our beta is. Our alpha for this equation is going to be 0 and our beta is just going to be 1. So therefore, our general solution is just y equals e to the 0x times c sub 1 cosine of x plus c sub 2 sine of x. I forgot. So our differential equations in terms of theta, so this really should be theta, theta, and theta. If you put x, it's not bad. So now this is our solution, which then can just be written as c sub 1 cosine theta plus c sub 2 sine theta. So here's our solution, and knowing that I'm going to need the derivative of this to find c sub 1 and c sub 2, what I'm going to do is I'm going to go ahead and say y prime is equal to, take derivative of c sub 1 cosine theta, negative c sub 1 sine theta, plus c sub 2 cosine theta. And so there is the derivative of my general solution. So now what I'm going to do is I'm going to go ahead and plug in to find my c sub 1s and c sub 2s. I'm going to start with the original equation, and I'm going to say 0 is equal to c sub 1 cosine of pi over 3 plus c sub 2 sine of pi over 3. And that's just going to give me 0 is equal to cosine of pi over 3 is just 1/2, so 1/2 c sub 1 plus sine of pi over 3 is going to give me the square root of 3 over 2 c sub 2. So that's plugging in to the original general solution. Now I'm going to plug into the derivative, and I'm going to use that. So I'm going to change up colors just so you know that this is the derivative, just to save some space. So I'm going to say y prime, which is 2, it's the solution when x is pi over 3, is equal to negative c sub 1 sine of pi over 3 plus c sub 2 cosine of pi over 3. Now, it's nice that we've already done this because now we're going to get 2 is equal to negative square root of 3 over 2 c sub 1 plus, and then 1/2 c sub 2. Now, again, I want to solve for c sub 1, c sub 2. There are multiple ways to do this. You could treat them as x and y and graph them and see where they intersect. You could use substitution by solving for one, or you can use elimination, which is what I'm going to do. I'm going to bring this over, and I'm going to add it to my solution for just the general, and I'm going to get negative square root of 3 over 2 c sub 1 plus 1/2 c sub 2. Now, the easiest thing to get rid of is going to be the c sub 1 because one's positive, one's negative, and all I would need to do is multiply the top part just by the square root of 3. So when I do that and add, I'm going to get 2 is equal to square root of 3 over 2 plus a negative square root of 3 over 2 c sub 1. So they're going to cancel out. And then when I have a square root of 3 times the square root of 3, I'm just going to get 3 over 2. And 3 over 2 plus 1/2 is going to be 4. So I get 4 over 2. So I'm sorry, I'm going to get 2. And after I do that, I'm going to solve for my c sub 2 by dividing both by 2, and I get c sub 2 is equal to 1. Plugging c sub 2 in for one of these equations, I can go ahead and solve for c sub 1. I'm going to go ahead and I'll plug it into this one. So I have 0 is equal to 1/2 c sub 1 plus the square root of 3 over 2. Subtract the square root of 3 over 2, so negative square root of 3 over 2 is equal to 1/2 c sub 1. Multiply both sides by 2, and so therefore c sub 1 is going to be negative square root of 3. So I found c sub 1, c sub 2. Now I can go ahead and plug it back in to my general solution, and so then my solution for this initial value problem is y equals negative square root of 3 cosine theta plus c sub 2, which is just 1 sine of theta. And there's the solution. All right, next part is what happens if we have a higher order differential equation, so greater than 2. Well, basically, it's just going to fall along the same. Anytime that we have real roots that are not repeated, it's going to fall in this form where we have c sub 1 e to the m sub 1 x. So where all we have to do is put our solutions into the exponent with our e. If we have repeateds, then it's going to fall into this category. So if it doesn't repeat, it's just e to the m sub 1 of x. But the next time this solution repeats, here we add in our x. Now if it repeats a third time, then it's going to be x squared e to the m sub 1 of x. And the more it repeats, it's just going to follow that form that if it repeats, 7 times, then the highest x you'll have is x to the 6, e to the m sub 1 x. And then if we have any complex roots, what will happen is we'll just, find our conjugate pairs and we'll be able to plug in the same way, all right? Where we find our alpha and our beta. So our first higher order is going to be y double prime plus y triple prime plus 3y double prime minus 4y prime minus 12y equals 0. And so the first thing that you need to realize is, well, we can first plug in m. So m cubed plus 3m squared minus 4m minus 12 equals 0. And then we look and we realize, hey, I've got to factor this. Now, I have no problem with y'all going ahead and plugging this into your graphing calculator and looking for your zeros where it crosses the x-axis, just using x cubed, x squared, x for your m's, and you'll be able to find it that way. Now, again, I'm going to do it to where, say, hey, I don't have that, so I'm going to use synthetic division, and I'm going to find all my possible zeros. So if you remember, you started this in Algebra 2, which you can find your p's and your q's, where p's are just your factors of the last term. Your q's are your factors of the first your leading coefficient. So here it's just 1, so they're all going to be 1. Here we have 12, so then that means that we're going to have plus or minus 1, because 1 goes in the 12. 2 goes in the 12. 3 goes in the 12. 4 goes in the 12. 6 goes into 12, and then 12 goes into itself. And again, those are all divided by 1 because our leading coefficient is just 1, so that's not bad. So these are all the possible zeros. So here we have, looks like we have up to 12 possible zeros that we can try. Hopefully I'll get lucky and I'll pick the first correct zero. And you know what? I'm just going to go ahead and try -3 and see if that works. So I'll plug it in. So now I'm using synthetic division. Again, you could use long division if you'd like. I know that you don't like long division, so we can just use synthetic division. I'm going to take all my coefficients, so 1, 3, -4, -12. And I'm going to bring down 1, multiply by -3, add, you get 0, multiply, you get 0, add, you get -4, multiply, -3 times -4 is +12, and I am either very lucky or I've already done this problem. And so I knew that -3 was going to be a solution. So we've actually found a solution. We have m sub 1 is equal to -3, and so that means my y sub 1 is just going to be e to -3x. Now, to find my other solutions, I'm going to go ahead and now take what's left, which this will be m squared minus 4 equals 0. Well, that's nice because I can solve that one pretty easily. Subtract 4 from both sides. I'm going to get m squared is equal to 4. Take the square root, where just m is going to be plus or minus 2. So then my m sub 2 is going to be 2, and my m sub 3 is going to be -2. And so then I can find my y sub 2, that's just going to be e to the 2x, and my y sub 3 is equal to e to the -2x. So that makes my general solution y equals c sub 1, e to -3x, plus c sub 2, e to the 2x, plus c sub 3, e to the -2x. And hopefully you find that that is not that bad. And we're done. I'll go ahead and box up my solution, and we're finished with that one. And only 2 more pages to go, and these last 2 pages will not take very long.